right, so chapter 1, lesson 5 is graph proportional relationships. So in the warm-up, it says label the coordinate plane. So this first one, this first arrow here is pointing to this vertical line there. What is that called? That is the y-axis. Very good. This one is pointing to that little point, that point right in the middle of the two lines. That's going to be the origin. Very good. And then this one is pointing to the horizontal line. What's that called? That's the x-axis. Very good. Now, on this side, we've got this first blank is pointing to the 1. What's that? That is the x-coordinate. Very good. And then this one down here is pointing to the 2. What's that? That one is the y-coordinate. Very good. And then this middle one right here, this is pointing to, it's pointing to the whole thing. What's that whole thing together called? An ordered pair. Very good. All right, so now the second part of the warm-up says graph the points 2, 3 and -3, -2, and then connect the 3 points on the coordinate plane and then describe the graph. So we've got 2, 3 says 1, 2, and then 1, 2, 3 right up there. And we've got -3, 1, 2, 3, and -2 down here. And then it says connect the 3 points on the coordinate plane. All right, so there's our graph. And of course, when we're graphing on the coordinate plane, we want to make sure we put our arrows in there. So describe the graph. What do you think about it? Good. This is, when I connect the dots, it's a straight line. So this is a linear function. Is everybody clear?
Yep.
So the points form a straight line.
Wait, is B after?
So the first thing we're going to talk about is identifying proportional relationships. Now you know we already talked about identifying proportional relationships before spring break, right? When we looked at the ratios in the tables, and if the ratios were equal, then it was proportional. If the ratios were not equal, then it was not proportional. Here, another way to determine if two quantities are proportional is to graph the quantities on the coordinate plane. Now this part that's written down in red and blue, I would like for you to write down. If the graph of the two quantities is a straight line through the origin, then the two quantities are proportional. Does everybody see how I've underlined the through the origin in blue? That's very important. Please make sure you underline that twice. So, for the first example, it says the slowest mammal on Earth is a tree sloth. It moves at a speed of 6 feet per minute. We want to determine whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing on the coordinate plane. And then we want to explain our reasoning. So the first step is to make a table to find the number of feet walked for 0 to 4 minutes. Now, I want you to write down the actual steps here. So, I want you to write down that step 1 is to make a table. Okay? And I also want you to write down step 2, which is graph the ordered pairs. Okay? So, while you're writing that, the first thing we need to figure out is how am I going to fill the table? Well, here, it says that the sloth moves at a speed of 6 feet per minute. What does per mean in math? Okay, so 6 feet per minute means multiply. Okay, so that means that we are going to multiply 6 times however many minutes, and that's going to give us the distance. Is everybody with me? Okay, so there is my equation from the word. So now we're going to make the table. So we're going to use that equation that we just came up with to fill our table. So at 0 minutes, 6 times 0 is 0. You see how I got that? At 1 minute, that's 1 times 6. 6 times 1, that gives me 1. 6 times 2, 12. 6 times 3, 18. And 6 times 4, 24. So now you can see from the table you have ordered pairs. So my first ordered pair is 0, 0. Does everybody see that? The next one is 1, 6. The next one is 2, 12, and 3, 18, and 4, 24. So we want to graph those ordered pairs. So here I'm going to graph 0, 0, 1, 6, right there, 2, 12, 3, 3, 18, and 4, 24, and then connect the ordered pairs. So when we connect the ordered pairs, what does it look like? Okay, so this is a straight line that passes through the origin. So is the number of feet traveled proportional to the number of minutes?
Yes.
Yes, it is. All right, so for the got it example, it says James earned $5 an hour babysitting. Determine whether the amount of money James earns babysitting is proportional to the number of hours he babysits by graphing on the coordinate plane, and then explain your reasoning down here, okay? So the first step is to make our table, right? So how do I fill the table? Well, we have to figure out what our equation is, right? Now, see what I wrote down, what I underlined here in red? It says James earns $5 an hour, or $5 per hour. What operation is that? That is multiplication. Very good. So we're going to multiply in order to get the dollar amount, okay? The amount, we're going to multiply $5 times how many hours, right? So we're going to multiply 5 times H to get the amount that he earns. Is everybody with me? And that's our equation that we take from our situation. So if I had 5, if he didn't work any hours, how much is he going to earn? 0, right? So we know that's, I just didn't put that number in the table. So here we have 5 times 1, which would give me $5. 5 times 2, 10. 5 times 3, 15. 5 times 4, 20. And 5 times 5, 25. Very good. So the next step is to graph it on our coordinate grid. So here we have 1, 5, which is about right there. Okay. We have 2, 10, about right there. We have 3, 15, which is up here. And then 4 and 5 don't fit, so I'm just not going to put those on. We did say that we have, if he worked 0 hours, he's going to get $0, right? Didn't we say that? All right. So when we now connect the dots, this is what it looks like. So what can I say about the proportionality? So if you look back in the words, you guys, you can see how you're going to answer. See, it says determine whether the amount of money James earns is proportional to the number of hours he babysits. So we're doing the amount earned to the amount of hours. Is it proportional? So your final answer is yes, the amount James earns is proportional to the number of hours he works. And we know that because this is a straight line that crosses through the origin. Very good. Let's write that down too. The graph is a straight line that crosses through the origin. So yes, the amount James earns is proportional to the number of hours he works. For example 2, it says the cost of renting video games from Games Incorporated is shown in the table. Determine whether the cost is proportional to the number of games rented by graphing on the coordinate plane and explain our reasoning. Now, we already have a table, so step 1 is not going to be create a table, right? Step 1 is to write the ordered pairs. So from the table, you can see x comma y. The ordered pairs are 1 comma 3, 2 comma 5, what's else? 3 comma 7, and 4 comma 9. Those are the ordered pairs. Step 2 is to graph on the coordinate plane. So when we graph, this is what the graph looks like. Okay? So, do we have a straight line? Yes. That's good, right? But what else does it have to do? Has to pass through the origin. Does this one pass through the origin? No, it does not. So because it does not pass through the origin, the cost of the video games is not proportional to the number of video games rented. Is everybody clear with that? Now, I want to let you know, I want to point out that a way for you to check is to look at the ratios. So here, we've got 1, this is 1 1/3, 1 over 3, right? 1 to 3. That's this ratio, right? Here, this ratio is 2 to 5. This ratio is 3 to 7. If I look at those ratios, 1/3, 2/5, are they equal? No, they're not equal. Because the ratios are not equal, we already learned this before spring break, right? They are non-proportional. Very good. So here it says the table shows the number of calories an athlete burned per minute of exercise. Determine the number of calories burned whether the number of calories burned is proportional to the number of minutes by graphing on the coordinate plane. So we know here what we are comparing. We are comparing, says determine whether the number of calories burned is proportional to the number of minutes. Is everybody clear with that? So here is the table. What are my ordered pairs? So the first one is what? 0, 0. Very good. The next one is 1, 4. The next one is 2, 8. Perfect. And the last one is 3, 13. So there are my ordered pairs. So now we have our ordered pairs. Now we can graph them on the coordinate grid, okay, or the coordinate plane. So here we're going to graph 0, 0, 1, 4, 2, 8. You should be graphing this right now. And we have 3, 13, way up there. All right, so now the next step is to connect the dots, right? So now when we connect the dots, this is what it looks like. Is everybody with me? All right, so we want to know, is the number of calories burned proportional to the number of minutes? Who thinks yes? Who thinks no? Okay, if you look at this graph, first of all, we see that it goes to the origin, right? That is one thing that has to happen. The other thing that has to happen is that it has to be a straight line. Is this a straight line? No, this is not a straight line. It is, so therefore it is not proportional. The graph is not a straight line through the origin, so it is not proportional. Okay? The other way that you can check this is if you look at the ratios. Remember I told you? Look at the ratios. Here this is 1 to 4, right? 1 to 4. This one is 2 to 8. So that's 2 to 8. This one is 3 to what? to 13. So here, 1 to 4, 2 to 8, yeah, those are equal, right? Those are equal. But are those equal to 3 to 13? Those are not equal. So because the ratios are not equal, this is the check, because the ratios are not equal, then the situation is not proportional. So example 3 says, which batting cage represents a proportional relationship between the number of pitches thrown and the cost? And we want to explain. So first of all, here we've got Fun Center and Softball Plus. We look at both of these graphs. Both of them are straight lines, right? But do both of them go through the origin? No. So which one is not proportional? Softball Plus is not proportional, and Fun Center, because that one is a straight line and goes through the origin, the red line is proportional. Is everybody clear?
Yeah.
All right, very good.